Hi my dear friends, welcome back to our YouTube channel. This is your ADC. So this is the second model in the diagonalization of 3 by 3 matrix 1 1 3 1 5 1 3 1 1. This diagonalization is valid only when if it's a symmetric matrix. It's a symmetric matrix first of all. Yes, 1 1 3 3 1 1 is right. 3 by 3 matrix, so it is 3 eigenvalues. The first step to find the eigenvalues of A. As we know that the characteristic equation of A is determinant of A minus lambda is equal to 0. So lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0. What about S1? Sum of the leading diagonals. 1 plus 5 plus 1, 7. S2 is sum of the minus through the leading diagonal. So 1. So this column and this row and this column 5 1 1 1. Right? Second diagonal 5. So 1 3 3 1. Third one 1. So 1 1 1 5. So we get 5 minus 1 4, then 1 minus 9 minus 8, 5 minus 1 is 4, so it is 8 minus 8 0. And S3 is the determinant of the matrix, so we get minus 36. So when I substitute in this equation, I found that this is the characteristic equation, lambda cube minus 7 lambda squared plus 0 lambda and minus of minus plus 36 equal to 0. Now find out the 3 eigenvalues because it's a 3 cubic polynomial, and let us see that this is the 36 even number, so better can go for the plus 2 or minus 2. So I start with the long division method by choosing minus 2 by taking the highest coefficient. Lambda cube is 1, lambda square is minus 7 and lambda is 0, constant 36. By taking minus 2 adding vertically here, starting the 0 1 1 into minus 2 minus 2 minus 9 into 2 plus 18, so it is minus 36 0. So this is the first eigenvalue, and the reduced equation be lambda square minus 9 lambda plus 18 equal to 0. The sum of the values is minus 9, product is plus 18, so 3 and 6. So finally I found that lambda 1 is minus 2, lambda 3 is lambda 2 is 3 and lambda 3 is equal to 6. So these are the my eigenvalues. So once we get the eigenvalues, we know that what is the D. What's the D matrix for this? Minus 2, 0, 0, 0, 3, 0, 0, 0, 6. So how we will get this diagonal matrix? By using the orthogonal transformation. The step number 2 is to find the eigenvectors. To find the eigenvectors of A. As we know that A minus lambda into x equal to 0 matrix, subtract lambda from this, multiply by the vector x1, x2, x3. So 1 minus lambda x1 plus x2 plus 3x3 equal to 0, x1 plus 5 minus lambda into x2 plus x3 equal to 0, 3x1 plus x2 plus 1 minus lambda into x3 is equal to 0. Is right? This is my superstar equation. This is my superstar equation, 1 minus lambda. Now substitute lambda is equal to minus 2. What we will get? So 1 minus of minus plus 2. 1 minus of minus plus 2. So we get it is 3x1 plus x2 plus 3x3 equal to 0. Second equation x1. 5 minus of minus plus 7. 7x2. Then x3 equal to 0. I don't go for the third equation because for cross multiplication rule, once when we have two distinct equations, it's more than enough. So let's apply the cross multiplication rule. Start the middle variable, the coefficients are 1 7, 3 1, again 3 1, 1 7. So x1 which gives 1 1s are 1 minus 7 3s are 21, x2 gives 3 minus 3 0 and x3 gives 7 23, 21 minus 1 we get is 20, this is minus 20. This is the multiples of minus 20, we get x1 is equal to 1 0 minus 1. This is the first eigenvector which is corresponding to the eigenvalue lambda equal to minus 2, right? What about the second one? So what about the second case? The second case is when lambda equal to 3. Substitute lambda equal to 3 here. 1 minus 3 is minus 2x1 plus x2 plus 3x3 is equal to 0. Second equation x1. 5 minus 3 is plus 2. So 2x2 plus x3 is equal to 0. Once again, these two are two distinct equations. So let's start the third one. No need to bother with the third one. Can you apply the cross multiplication rule? 1 2 3 1 minus 2 1 1 2. So this will give the x1 value. This is the x2 value. This is the x3 value. So x1 by 1 into 1 is 1 minus 3 2s are 6 is equal to x2 by 3 1s are 1 minus plus 2 is equal to x3 by minus 2 into 2 is minus 4 minus it is 1. So which gives x1 by minus 5, x2 by 5 and x3 by minus 5. I think so it is a multiples of 5 only. I go with the minus 5 because there are two terms are there. So what about x2? x2 is equal to 1 minus 1 1. So this is my second eigenvector which is corresponding to the lambda equal to 3. What about lambda is equal to 6? Case number 3. By putting lambda is equal to 6, what we will get? 1 minus 6 minus 5x1 plus x2 plus 3x3 is equal to 0. Second equation x1 5 minus x minus x2 plus x3 is equal to 0. So two equations are distinct. Can we apply the cross multiplication rule once again? We will get the third eigenvector. So we start with the middle variable. So 1 minus 1. Here 3 1. And coming back to the first one minus 5 1. Again the same middle one 1 minus 1. This gives the x1. This gives the x2 value. This will give the x3 value. So x1 by 1 1s are 1 minus or minus plus 3. Right? x2 by 3 1s are 3 minus or minus plus 5. And x3 by minus 5 into minus 1 is plus 5 minus 1 into 1 is 1. So which gives x1 by 4, x2 by 8, x3 by 4. I think so it is a multiples of 4. Let's multiply this one. We get x3 is equal to 1 2 1. 1 2 1. So these are the three eigenvectors corresponding to the given matrix A to the eigenvalues minus 2 3 6. So this is the case 1 2 3. And third step, let us verify that these eigenvectors are pairwise. So step number 3, verify x1, x2, x3 are pairwise orthogonal vectors. Pairwise orthogonal vectors. So how to verify these are the pairwise orthogonal vectors? Separate video I made for you. How to check the pairwise orthogonal vectors? Please kindly go and watch. Right? Now see that. How to check? Yeah, x1 transpose x2 values. x1 transpose this x1 transpose 1 0 minus 1. What about x2? x2 is this one 1 minus 1 1. Multiplication 1 into 1 is 1. 0 into minus 1 is 0. Minus 1 to 1 is minus 1. So equal to 0. That's right. What about x2 transpose x3? x2 transpose. So 1 minus 1 1 and x3. What's x3? 1 2 1. So matrix multiplication 1 into 1 is 1. Minus 1 into 2 is minus 2. 1 into 1 is 1. So 1 plus 1 2. 2 minus 2 0. Is correct. And the finally, so what's the combination? 1 2 2 3 and 1 3. So what's the 1 3? So x1 transpose x3 is equal to what's x1 transpose? 1 0 minus 1 and x3 is 1 2 1. So once again 1 to 1 is 1, 0 to 2 is 0, minus 1 to 1 is minus 1 is equal to 0. So hence everything is 0 0 0. That means that is called pairwise orthogonal vectors. Right? Pairwise orthogonal vectors. Step number 4. To construct the normalized model matrix. What is a normalized model matrix? Whose columns are the normalized eigenvectors. So let us find out the length of the eigenvectors first. What's the length of the first eigenvector? Sum of the squares of the values. So 1 square plus 0 square plus minus 1 whole square equals 2. Second one, L of x2 is sum of the squares of this value 1 square plus minus 1 whole square plus 1 square is root 3. x3, sum of the values is 1 square plus 2 square plus 1 square root 6. So the first column divide by its length. So 1 by root 2, 0 minus 1 by root 2. The second column, the second eigenvector divide by its length 1 by root 3 minus 1 by root 3, 1 by root 3. And third column is the third eigenvector divide by its length. So 1 by root 6, 2 by root 6 and 1 by root 6. So this is my normalized model matrix. Hence it is an orthogonal matrix. Very important because once they are pairwise orthogonal, so obviously it is orthogonal matrix. n transpose equal to n transpose n equal to I. So this is step number 4. What is step number 5? To find the diagonal matrix. So step number 5, to find the D. What's the D? So D is nothing but the diagonal matrix D is called n transpose A into n. So D is equal to transpose of this matrix. So 1 by root 2, 0, minus 1 by root 2. Then here 1 by root 3, minus 1 by root 3, 2 by, this 1 by root 3, 1 by root 6, 2 by root 6, 1 by root 6. So this is the n transpose A. Here is the given matrix here, 1, 1, 3, 1, 5, 1, 3, 1, 1. And n as it is this one, 1 by root 2, 0, minus 1 by root 2, and 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 6, 2 by root 6, 1 by root 6. Let us multiply these two, what we will get? So when I multiply these two matrices, I thought it is 1 by root 2 is common in the first row, so I put 1 by root 2. Multiply the numerator wise, 1 into 1 is 1, plus 0 into 1 is 0, minus 1 to 3 is minus 3. Similarly, the same row with the second column, in here 1 by root 2 is common, so 1 into 1 is 1, plus 0, minus 1, is right? And 1 by root 2, 0, minus 1 by 2, so 1 by 2 is a common, 1 into 3, plus 0, minus 1, is right? 1 into 3 plus 0 minus 1. So continue like that. The root 3 is the second row and root 6 the third row concept. So multiply the numerator alone. 1 into 1, 1, minus 1 plus 3, right? Then 1 into 1, 1, minus 5 plus 1, right? 1 into 3, 3, minus 1 plus 1, right? Then root 6 is common, the third row. Then multiplication the numerator wise, 1 ones are 1 plus 2 plus 3, right? 1 into 1, 1, 5 twos are 10. Plus 1 ones are 1. Then 1 into 3, 3. Plus 3, 2 into 1 is 2. Plus 1 to 1 is 1. And this n matrix as it is. The n matrix is as it is. The n matrix is as it is. So let us see the matrix multiplication. After multiplying this, let us simplify this. 3 minus 1 minus 3 is minus 2 by root 2. This is 0. 3 minus 1 is 2 by root 2. And this becomes 3 by root 3. This becomes minus 2 plus 1. It's minus 3 by root 3. And this is plus 3 by root 3. This is 6 by root 6. This is 12 by root 6. This is 6 by root 6. Now this is as it is the n matrix. Now multiplying this one with this. Again 1 by root 2, 1 by 2, so 1 by 2 is 2 only. So 1 by 2 is taken outside. Minus 2 into 1 is minus 2. 0 into 0, 0. 2 into minus 1 is minus 2. Right? And again 1 by root 2 into 1 by root 6. It is 1 by root 6 taken outside. This row and this column, the denominator is 1 by root 2, 1 by root 2, 1 by I think 1 by root 3. So root 2 into root 3 is root 6 taken common, right? So minus 2 into plus 1 is minus 2, 0 into 1 is 0, and 2 into 1 is plus 2, right? And this 1 by root 2 into 1 by root 6, 1 by root 2 is taken common, then minus 2 into 1 is minus 2, plus 0, 2 into 1 is 2, right? The similar way to find out this middle row and this one, 1 by root 3 into 1 by root 2. So 1 by root 6, 3 into 1 is 3, minus 0, minus 3. So 0, minus 3. Alright? And the middle column and middle row. So root 3 into root 3 is 1 by 3. 3 into 1 is 3. Minus 3 into 1 is minus 3. 3 into 1 is 3. So I think 6 minus 3, so minus 3 by 3. Otherwise it is 3 into 1 is 3, yes, right? Minus 3 here, yes, minus 3 into 1 is minus 3, 3 into 1 is 3, then finally 3 into 1 is a 3, so root 3 into root 6, so 1 by root 18, 1 by root 18, I think this also comes as minus minus plus, yes, 1 by root 3, 1 by, yes, minus 1 by root 3, so minus 1 by root 3, so this comes a minus minus plus, yes, right. Now, 1 by root 3 into 1 by root 3, 1 by root 18, 3 into 1 is 3, minus 3 into 2 is minus 6, 3 into 1 is 3, that's correct. The last row, root 6 into root 2, so 1 by root 12, 6 into 1 is 6 plus 12 into 0 is 0. 6 into minus 1 is minus 6. Then root 6 into root 3, 1 by root 18. 6 into 1 is 6 minus 12 plus 6. And what about the last one? Root 6 into 6 is 6, 1 by 6. 6 into 1 is 6 plus 12 into 12 is 24. 6 into 1 is 6. So finally what we'll get after multiplying this becomes minus 2 minus 2 minus 4. Minus 2 minus 2 minus 4. Minus 2 minus 2 minus 4. So minus 4 by 2. This is minus 2 plus 2 0. Minus 2 plus 2 0. The second row 3 minus 3 0. 3 plus 3 plus 3 9. 9 by 3. Then what about 3 plus 3 6. 6 minus 6 0. And 6 minus 6 0. 6 minus 6, that is 6 plus 6 12. 12 minus 12 0. And 6 plus 6 is 12. 12 plus 24 is 36. So 1 by 6 by 36. So when we get D equal to minus 2 0 0 0 3 0 0 0 6, is exactly what I was in state that in the beginning. Once we get the eigenvalues, we can easily know what is the final output. The final output is nothing but the diagonal matrix whose leading diagonal elements are nothing but the eigenvalues of the given matrix, lambda 1, lambda 2, lambda 3. So this is the procedure to diagonalize the 3 by 3 matrix. Thank you so much for watching our YouTube channel ADC Max. Thank you.